I'm Anil Kumar. Welcome to my series on small increments and approximation. In this video, we will learn how to estimate a value of a square root. As an example, I have taken up estimate the value of square root of 24.6 to 2 decimal places. Now we'll use this technique of approximation to estimate. It involves derivatives. Now, let's try to understand the basic concept. So we'll try to sketch the graph for the function, which is square root of x, which will be kind of like this, right? So that is how it may look like. Now, if I'm saying estimate the value of square root of 24.6, then what we need to really figure out is what is square root of 24.6. This is what we need to find. Okay, what we know exactly that square root of 25 is 5. That's what we know. So we could estimate the value. It has to be slightly lesser than 5. Okay, 24.6 is very close. So we could write this as 25 minus some number, right? So which is 0.4 in this case, 0.4. So that becomes square root of 26, correct? So with this common difference of minus 0.5, we should be in a position to get the fairly accurate estimate. Let's see how. So the concept here is that if I have a point here, let's say, so what I'll do here is I'll draw a tangent line here. This tangent line is being drawn for a point where the x value is 25 and the y value will be 5, right? That is the curve which we have. So our function here is square root of x. Now, we are actually interested in getting the value which is slightly less. That is to say, we want a value here which is slightly less. Let's say this point, let's break this, it's not very accurate. So we say this is our point of interest, which is 24.6. You get an idea, right? On the curve, the accurate value is right there. This is the exact value of 24.6. We can use calculator to figure this out. But without calculator, how do we estimate? So what we will say is that, well, that is the slope of the tangent line at 25. So what we will do here is we'll try to understand that the function f of x equals to square root of x actually defines all the values, right? So if I take the derivative of this function, that is to say if I write y dy over dx, the derivative of this function is 1 over 2 square root of x, right? So that becomes the derivative. So for a small change, this is a small change. For a small change, we will have, let's say we have changing the value of x by x plus delta x. In that case, the y value will actually be, exact value be f of x plus delta x. In our case, that delta x will be minus. But anyway, in general, we could write like this, right? But the approximation here is that we could approximate that this change is minimal, right? So we say a change in y for the change in x is basically equal to dy by dx. And that is especially true when delta x is approaching 0, right? That is how you define dy by dx, correct? Derivative. So from here we conclude that for a minor change, which is 0.4 for us, we could find a minor change in y also, right? So if you look into this, we can say approximately the value of change in the value of y should be dy dx times delta x. Correct? Now in our case, we are looking at the x value of 25, right? So what is dy dx at x equals to 25? So if I substitute 25 here, I get 1 over 2 square root of 25, which is 1 over 10. Correct? Now, for a change of minus 0.4, what is the change in y? So what is the change in y? So change in y will be dy dx at x equals to 25 times delta x for the given question, right? This is multiplication, correct? So in our case, it is going to be 1 over 10, that is at 25 the change, and this particular change is given to us as negative 0.4, correct? So basically, this is equal to negative 0.04. Perfect. And therefore, we can estimate, right? So what is our estimate? So now we can say that the square root of 24.6 is approximately equal to square root at 25, which is 5, minus 0.04, which is basically equal to 4.96. Does it make sense to you? Correct? So we estimated the change as a variation from the position, right? So as a ratio. Do you see that? So worked out like a ratio. Of course, this has some errors, but it's fairly accurate. Now, as a different exercise, I'll provide you with links for that. We may have to find percentage error in such changes in different ways. So that will be our next exercise. However, I hope this point is very clear, right? So if I have to calculate square root of 24.6, for example, I will actually calculate square root of 25, and then using the rate of change for a small change in x value, I can find what will be the plus minus value, right? So in this case, it was 0.04 minus, so we deducted that and found this value to be 4.96. Is that clear? Correct? Now, as an exercise, you could try something else. You could find square root of, let us say, 65, right? So you could try, what is the square root of 65? Estimate this, right? So that could be a question for you to practice. And then using calculator, you could also see the percentage error, which will be very minimal, right? So these approximations to two places are fairly accurate for most of the questions. So I hope you understand and estimate the trick. Now this is involved in many questions where calculator is not allowed and you have to calculate such values. So it really helps. I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.